Welcome to the 13th session in our webinar series with the Alliance for Water Efficiency. WaterSense and AWE started this series in 2015. The goal is to reach different audiences that have a role in ensuring outdoor water efficiency, including landscape professionals, local governments, and water utilities. We've had 12 successful webinars to date, many of which highlighted how local governments and the outdoor industry are working together to reach consumers. All of our webinars have been recorded and are available for on-demand viewing for people who are busy during the day when we hold the live session. Let's cover a few housekeeping topics before we get started. All attendees were muted when they entered the webinar to minimize background noise. To ask questions, you can type those in the chat box at the lower right-hand corner of your screen, and we will answer those questions at the end of the webinar. This presentation will be available on the WaterSense website, as well as AWE's YouTube channel following the presentation. We'd also like to hear from you with a few polls. So first, who do we have on the call today? Karina, do you want to go ahead and share those answers?
Yep, they should be visible right now.
I can't see them.
Okay. Let's try going on to the next poll.
Okay. So our second poll, what part of the country are you calling from? And Karina, I think everyone else can see it, but I can't. So if you want to share those results.
Okay, we're sharing them right now. It looks like most people are from the West, and then we have about an even split between Southwest and Midwest, a couple of Southeast and a couple of Northeast.
Great. So today's webinar is Reducing Outdoor Water Use with Microirrigation. We have three featured speakers today. The first is Marianne Dickinson. She is the president and CEO of AWE and the executive director of the California Water Efficiency Partnership. Marianne has over 40 years of experience, having worked at the Metropolitan Water District of Southern California, the South Central Connecticut Regional Water Authority, and the Connecticut Department of Environmental Protection. She is a graduate of the University of Connecticut with a degree in environmental planning. Marianne has authored numerous publications on water conservation, land use planning, and natural resources management, and has co-produced 2 films which have aired on public television and community cable stations. Our next speaker is Julius Duncan. He is the environmental engineer for outdoor water programs with WaterSense. He works with the technical team on new outdoor product specifications and coordinates with the professional certifying organizations to develop helpful resources to communicate with certified irrigation professionals. He has a master's degree in agricultural engineering from the University of Georgia and a bachelor's degree from Florida A&M University. Our final speaker today is Bernd Leinauer. He is a professor and extension turfgrass specialist in the Extension Plant Sciences Department at New Mexico State University. Dr. Leinauer's extension and research program focuses on developing water management strategies aimed at reducing the amount of potable water used for irrigation. These strategies include the screening for low water use, cold and salt tolerant turf species and cultivars, irrigation with recycled and/or high saline water, and subsurface irrigation. Dr. Leinauer has authored and co-authored a book chapter, over 70 scientific peer-reviewed research papers, and almost 200 reports and abstracts. He was part of a group of NMSU researchers that received the United States Department of Agriculture's Outstanding Integrated Program Waters Resources Team Award. In 2012, Dr. Leinauer received the college's Distinguished Research Award, and in 2013, he was awarded New Mexico State University's Distinguished Career Award. In 2017, he was named Fellow of the American Society of Agronomy, and in 2018, he received New Mexico State University's Regents Professorship. So now I'd like to turn the presentation over to Marianne, who will discuss AWE's outdoor water research.
Thank you very much. Just wanted to take an opportunity during this webinar today to let you know about a number of studies that have been finished and will be finished shortly. So if we could go to the next slide. Just a little background on the kind of water research that we're doing in the outdoor sector. What we wanted to do is help water utilities across the country get the right kind of information that would give them the ability to undertake that the outdoor sector. So the research that we were undertaking was aimed at providing actionable information that could lead to direct implementation of programs, but provide data on the savings potential and the actual water savings that have been achieved from various research projects around the country. So the first step that we did was in our phase 1 of this research was to take a look at what had been done across the country already. We conducted a review of the research that had been conducted both at the university level and also most particularly by water utilities who had undertaken programs and had conducted comprehensive evaluations of those programs. So those programs were analyzed, and then the synthesis of the research results were provided in the report, identifying holes in that research. What kinds of outdoor programs were not looked at in research that might be targets for research going forward. So the phase 2 of our project was to take that list of undone research and to take a look at which topics would be the most important for us to pursue. We wanted to take new empirical research, undertake that research, and make sure that that research would provide relevant, statistically validated and peer-reviewed information to again help water utilities design programs going forward. So the first set of topics that were chosen for this phase 2 research were chosen by the AWE membership. We assembled a project advisory committee, solicited our membership for those who wanted to participate, and so then we move forward with the phase 2. What you see on the screen right now is the cover of the phase 1 report. It's posted on the AWE website, and it's a free downloadable PDF. Next slide, please. So what we wanted to then focus on is just let you know what we actually have done so far in that phase 2 research. What outdoor water savings and water demand studies have we undertaken so far? One study we did in conjunction with the American Water Service Company and the consulting firm WaterDM, and it was a study meant to take a look at what the role might be of smart controllers and smart meters to shift peak demands into non-peak periods to help water utilities lower the peaks that they were facing in very particularly heavy summer peak months. And it was a small study that was undertaken to determine whether technology could do that shift automatically. It wasn't aimed at actually monitoring savings, it was aimed at shifting the peak, shifting the times of irrigation to periods that would be more effectively managed by the water utility. That study has been completed, and the results of that study are also posted on the AWE website. The next 2 are studies that are about to be released or will be released soon. The study that's about to be released is a study looking at landscape transformation programs, typically often called Cash for Grass, but often also by other names. And what we did was we solicited not only funding but data from 15 different water utilities across the country, and looking at their reasons, the rationale for the programs, why they undertook them, what kinds of savings they experienced. And then from that study then developed market recommendations for how these kinds of programs can be undertaken in the future and what recommendations can be made to positively ensure their success. The study is nearly complete. We had a presentation on it at the WaterSmart Innovations Conference in Las Vegas last week. We will be releasing the documents in the next couple of weeks, and we'll be rolling out public information as well as specific information from the study for AWE members. The third study is on drought restrictions, analyzing the impact of drought restrictions in reducing outdoor water use and what the relationship of those restrictions are to long-term savings. In that study, we have 14 participating and funding water utilities and agencies. And we're going to be sending out in the next month or so a utility survey to a broad spectrum of utilities across the country. We'll send that out in a few weeks or so to ask questions about experiences that might be relevant to the analysis in this study that might not be captured by those 14 utility case studies that we already have in this study. So look for that. If you're not an AWE member, but you'd like to be part of the study, if you're a water utility that has undertaken drought restrictions, I'd love to have you get in touch with us. Me at Maryann, MARYANN, at we.org. We'd love to include you in this analysis. And we expect the drought restriction study to be completed in the spring of 2019, and we will also make sure you all know when it's completed. So that's basically what I wanted to just bring everybody up to date on, and thanks everybody for the opportunity.
All right, thanks Maryann. And good afternoon, everyone. Today our webinar will go over how microirrigation can save water outdoors, as well as 2 new guides that WaterSense has developed. Outdoor water use can account for 30 to 60% of the total household water use. As much as 50% of that water is wasted due to overwatering, poor irrigation design, improper system installation and management, lack of maintenance, and improper scheduling. To tackle these issues, EPA is approaching outdoor water efficiency with the 3 Ps: products, practices, and programs. Our WaterSense labeled products help consumers reduce their water use and reduce water waste. We develop resources that promote water efficient practices, such as our WaterSmart Landscapes Guide and Irrigation Controller handouts. And our partners around the country have programs that spread the word about water efficiency. As many of you have probably experienced, water used for irrigation can be significant and can be one of the major culprits for water waste. Commercial facilities commonly have in-ground irrigation systems used to maintain an aesthetic landscape. Considering the facility type is important because outdoor water use may have to account for athletic fields, pools, spas, or vehicle washing stations. Each of these require a minimum amount of water use to retain their usefulness. Climate can affect the amount of additional water needed to irrigate the landscape. While the amount of water required by plants is generally constant, the amount of rainfall and evapotranspiration in an area is often variable. Evapotranspiration is a function of weather conditions and plant type and represents the theoretical water needs of the plant. The design and size of a landscape dictate the amount of water needed. Minimizing the size of the landscape needing irrigation can help keep water use under control. All WaterSense labeled products are independently tested by a third-party lab for efficiency and performance. That means that the product must show that it reduces water use by at least 20% compared to standard products on the market, while maintaining performance level that users will expect. We have more than 25,000 products certified, including over 800 certified irrigation controllers and more than 85 spray sprinkler bodies with integral pressure regulation. We've developed multiple guides for facilities large and small. The Best Management Practices Guide, WaterSense at Work, has details of the best practices for indoor and outdoor water efficiency. Chapter 5 of the guide goes over outdoor water use and ways for water-efficient landscaping and irrigation. The WaterSmart Landscapes Guide has information on designing a water-efficient residential landscape. Tips include use the right plant in the right place, use native or climate-appropriate plants, minimize slopes and areas of turf grass, use mulch, maintain healthy soils, and water wisely. We also recently released a brochure for irrigation controllers. It goes over the difference between clock timers and smart controllers and external devices that can be connected to them. Other tips, including hydrozoning, cycle and soak, and updating the irrigation schedule based on the weather, are also included in the guide. This spring, WaterSense finalized 2 guides promoting microirrigation, or commonly referred to as drip irrigation. For trees, shrubs, or flower beds, using overhead spray can cause overspray or water loss from water landing in areas away from the plants. Microirrigation has emitters placed directly at the root zone of each plant, where irrigation water is needed most. It also supplies water at a slower rate, so it has time to soak into the soil rather than pooling on the surface. The required flow rate will depend on the plant type, and the emitter type will determine the flow rate and distribution. Microirrigation systems use between 20 to 50% less water than conventional pop-up sprinkler systems. Installing a drip irrigation system can save more than 25,000 gallons of water per year when compared to a conventional pop-up sprinkler system. The first is a guide for irrigation professionals. Whether working with a new landscape or retrofitting to an existing landscape, consider areas where microirrigation can fit into your landscape design. Drip line emitters come with holes pre-installed into the piping. Point source emitters extend from the water line to reach plants further away. Multiple outlet emitters can allow for multiple lines to connect to the emitter, and microsprays operate at a low pressure to water plants. When scheduling irrigation, keep in mind the plant water requirement, weather conditions, soil types, slopes and sunlight, and the depth of the root zone. Lastly, the guide covers tips for maintaining a microirrigation system, ideas for helping your clients understand microirrigation, and some tips for troubleshooting. The homeowner version of our microirrigation guide contains the same details as a professional's version, but in an easier to read format. Many residential landscapes have a diversity of plants that would benefit from microirrigation. That includes flower beds, trees, shrubs, vegetable gardens, and container plants. It includes information that would help inform the do-it-yourselfer and also has information homeowners can use when preparing to work with an irrigation professional. The irrigation schedule is still important with microirrigation. Although the slow flow rate delivers water over the course of several hours, if left forgotten or if watering occurs during rain, water loss can still occur. These resources and more can be found on the WaterSense website. Next, we will have our featured speaker, Bernd Leinauer.
Okay, good afternoon, everybody. Thank you, Julius. You gave a great introduction already into the topic, and I don't have to talk much about it anymore when it comes to defining microirrigation. So next slide, please. Here we just see an overview of a few photos of what I will be talking, the microirrigation or subsurface drip irrigation under turf areas. We see here on the right side a cross section through a turfgrass root zone with the drip line cut right through, and you see it at about 4 inches below the grass cover, and same on the left. You see the drip line in the turfgrass soil, and below that we have an installation before the drip system is covered with more soil and then grass placed on top of it. Next slide, please. Now, Julius mentioned already that we see microsystem and drip systems already gaining a lot of ground in the landscape. Here we see some native landscaping in the here in the Las Cruces in southern New Mexico area. Next slide. And also in vegetable gardens, flower beds, microirrigation and subsurface drip is widespread. However, we see very little of it despite its efficiency and also its uniformity in turfgrass. It hasn't gained much ground on the turf. And that is, for us as university researchers, interesting. And maybe over the course of this presentation, we will be able to cover a little bit why that might be. Next slide. Now, in our toolbox for strategies for irrigation water conservation, with microirrigation and subsurface drip irrigation, we cover the area of increasing irrigation efficiency. And with that, we improve the water distribution, and by having a greater water distribution, we use less water. The grass plant itself doesn't need less water, or it does not affect the plant stand's water requirement, but it does affect the amount of water that is lost or wasted. Next slide, please. So here we just see a few photos from the area that I work on in the desert Southwest in the New Mexico and adjacent states. And we do see that our traditional way of irrigating turf areas, that is pop-up sprinklers, not always work efficiently and distribute water in a way that it is planned and intended. And then we see these nice patterns on these turf areas. Next slide. Here, this is one of my favorite. Sprinkler system not working properly can have various reasons that can have to do with that is not properly installed, but these systems also deteriorate in time. Keep in mind, we're working here with high pressure system, with plastic that wears out. We have change in flow and pressure, particularly in the residential landscape. As more houses go up and up, this then will affect the flow, and as years go on, our systems don't work anymore, and we can measure that. We go out, we do what's called an irrigation audit, and the irrigation audit then gives us a number, a value for the distribution uniformity. Next slide, please. And that distribution uniformity then plays an important role in calculating the water requirement, the irrigation water requirement, which is composed of ET, evapotranspiration, and then a certain crop coefficient that adjusts the model estimate for evapotranspiration for the plant stand that we deal with. But the distribution uniformity, which is a number anywhere from 0.2 to 1 would be perfect, goes into the denominator. So when we look at the next slide here, just based on an irrigation non-uniformity, distribution non-uniformity, what I call it, or the proper term distribution uniformity of 0.5, which is a number that we see a lot, doubles actually our irrigation requirement, and has nothing to do with the plant stand. It is just a number that adjusts for an irrigation system that is not working properly, and that is still a major issue in landscape irrigation. It's not so much the plants that we select; it is actually the way we distribute water, particularly when it comes from a sprinkler system. Next slide, please. So this is a slide that Julius already showed, and he pointed out that 50% of the water is wasted. That is certainly true, and that actually might be at the low end. In reality, the water that we that we waste or that is used for a purpose that it's not intended for could very well be much higher. Next slide. Because when we calculate irrigation requirement and use the DU, we only address the irrigation non-uniformity on the grass, but we also deal a lot with water that is wasted through runoff or overspray, particularly in the residential landscape where we have areas that are not perfectly square shaped and would be easy to irrigate from a sprinkler system. So runoff and overspray, losses to wind are key losses in the urban landscape irrigation and account for a significant amount of water wasted. Next slide. So here we have a subsurface drip irrigation system installed. This is actually a project on a golf course. I'll talk about this a little bit later in more detail. And they put this in, or the golf course here has decided to go with subsurface drip on a tee box because they want to limit the irrigation application to exactly the area that needs to be irrigated and don't want to waste water due to overspray. Next slide. So here we have a few products that are sold on the market. We have the 4 key players here. We have Netafim, Toro, Hunter, and Rainbird. They all have their subsurface drip systems, their product lines that can be installed in turf areas. Next slide. This is a typical design for turf. We have usually a header or 2 header lines here on the top and on the bottom that can be oversized, 3/4 or even an inch, depending on the size of the area. We have a flush valve, an air release valve. And then because of these drip systems that operate usually on a lower pressure than our traditional sprinkler systems, we work with a pressure regulator, of course, a valve that turns the water on and off. And a key component for a drip system is the filter. We will talk about this a little bit more later in that presentation. We put the system about 4 inches deep or 10 centimeters. 3 inches is also fine, 4 inches, and in a standard installation, we work on a 1 foot spacing, 12 inches. So we have 12 inches between the drip lines and also 12 inches between the drip emitter. So we have about a 1 foot grid. That's sort of the standard installation. Next slide. The manufacturers give out their information and provide also great help for the installation. Here, sometimes, and unfortunately I don't show this here on this slide, installations are also just on one drip line that is looped around several times through the area that needs to be irrigated. And for that, we need to know exactly what our water pressure is, because water pressure, the spacing, and the flow of the drip emitter then determine the maximum length of your drip line. That is important to consider, because if you extend it too far out, if you run your drip lines too long, then you're dealing with pressure losses and the system is not working properly and uniformly. So in this case, we look at the right table here. If we have an emitter spacing of 12 inches, we look at an emitter flow of 0.3 gallons per hour. That's kind of the standard emitter that we use in turf applications. And if we had an inlet pressure at the header line at the valve of about 40 psi, then we could run 315 feet on a single lateral length, and this is a number that should not be exceeded. Then the system is not irrigating properly. Next slide. Also important is here on the right, showing on the right is the flush valve. Very important. This is an automatic flush valve that stays open until the zone, the system is fully pressurized, and any potential debris or sediments or whatever the possibility is that can accumulate inside will flush out and then will not cause the emitter clogging. On larger areas, an air release valve is important and is usually installed at the highest end of your irrigated zone. The flush valve on the lower side, on the lowest side. Air release valves play a role also when you work on a slope, because you don't want to have air pockets to build inside the system and then prevent again from water being released through the system properly. Usually on residential turf areas that are more flat or just very lightly sloped, the system de-airs easily through the drip emitter, but if there is concern, then an air release valve should be installed. Next slide. Here we see some drip systems that were put in sloped areas. That's right now the biggest market probably for drip systems are on golf courses or park areas, public park areas that are severely sloped and that are very hard to be irrigated from a sprinkler system, because if you had a sprinkler pop up, the water would just run downhill, and in this case here in the top left, water would just accumulate in the bunker and would not be available to the grass plant. So this is a perfect example for a subsurface drip system. Next slide. This is a little bit, just for the next few slides, a little bit of an overview of what we have looked at in research and some of the water savings that we have come across. This was a part of a PhD project that was conducted in our program, and we compared seashore paspalum, which is a warm season species, and Bermuda grass, also a warm season species. Both of them were either drip irrigated or sprinkler irrigated for 3 years at 50% below ET replacement. So this is a significant crop coefficient. I understand these are warm season grasses, can hold up to the drought a little bit better. But still, you can see the difference here. On the left side, you have the same amount of water applied to these two grasses that results in a higher quality, uniformity, and a greater aesthetic appeal than on the right side, which is the sprinkler irrigated part, and where you see the grasses already go into drought stress. Some areas go dormancy. There is also some uniformity issue. So overall, the aesthetic quality of that sprinkler irrigated turf is lower, maybe not acceptable for a turf manager or the end user, and the result would be that the run time would be increased and more water would be put out. So that's where you have a higher water use here on the sprinkler irrigated compared to the drip irrigated. Next slide. We tried to push the envelope even further, and in 2017, we irrigated for a full year Bermuda grass at 10% of ET, so 90% below ET replacement. And you see the difference between drip irrigated turf and sprinkler irrigated turf. Now, there was, of course, there were a few rainfall events in between that helped us keep the grass alive. We generally do not recommend irrigating at 10% ET other than for scientific purposes. what we've learned here from this, and this is a demonstration project. This cannot be published because at the end we killed the grass and we cannot replicate the study. But what we've learned is that when we work and when we irrigate at much lower amounts with very high crop coefficients, then it is better to place the water exactly at the root zone, because you don't have to face these losses that a sprinkler system provides. So you don't spray or throw water into the atmosphere where it's exposed to transpiration, and then it has to trickle through the soil first, where you have more losses. Lower amounts are better placed directly in the root zone, where the grasses can pick up the water, or the plants pick up the water where it's provided. And this goes right into what Julius already mentioned before. Next slide. The subsurface strip also, of course, has been used, and there's a lot of information coming out of field crops and row crops. And there, the reported benefits are also that you have less of a disease incidence, and you have a much lower pesticide requirement than on sprinkler or flood irrigation or whatever it is that you use as alternative means. We saw this 1 year also on our plots. And this is what we can see very nicely here, that on subsurface drip irrigated areas, you have a lower disease incidence. In this case, it's brown patch rhizoctonia. And sprinkler irrigation, which keeps the canopy moist, which is perfect growing media for the fungus, and then causes the fungal disease that then would have to be treated by means of fungicide. With SDI subsurface drip irrigation, where you only keep the root zone moist and the canopy always dry, the fungus cannot grow, and you have less disease. Next slide. This is was two photos here of workshops that we conducted through the Extension Service. On the left side, this was a residential turf. On the right side, that's a school, a middle school here in Las Cruces. The area here further up towards the umbrella here is only 12 feet wide, and would have been very hard to irrigate from a sprinkler system without causing significant overspray. So they consulted us, and we decided to put subsurface strip in, and then grass was placed on top of it. Next slide. You can also retrofit turf areas with subsurface strip. We use a trencher here that's shown top right here, an easy trencher. On the left, we put in here trenchers in the subsurface strip into an existing Bermuda grass lawn. And on the right, this is one of these tee boxes on the golf course where we installed drip line into existing cool season grasses. Next slide. I mentioned before that one of the benefits and water conserving benefits of subsurface strip is that you can follow the contour of the landscape exactly, which is near impossible to be done with a sprinkler system, where you work with full circle, half circle, part circle, and there is always, almost inherently, with the design of the landscape, overspray. Here we worked with the flexible 1-inch PVC tubing that follows exactly the shape of the turf, and then we use what's called the so-called blazing saddles that then connect the drip lines to the header lines. Next slide. I mentioned the filters on the bottom here. You see the valve box with the pressure reducing valves and the screen filter. It is imperative that filters be used with these types of system, regardless of where the water comes from. Even if it's city water, potable water, we always recommend the use of filters. Next slide. This is a filter on a drip system that was not checked for 4 years, and you see the buildup on the outside. We recommend that when you have the subsurface drip system, you check the filter at least once a year, if not more often. And if there is buildup, this can be algae, there can be some kind of other debris. You're not always 100% sure what comes in your water, but it needs to be filtered out because you do not want to have your emitters clogged. We usually then soak these screen filters either in vinegar or in CLR for 24 hours, and that gets them going again. Next slide. This is just a photo of our research area where we have almost two acres under subsurface drip irrigation, and there we work with an industrial size sand filter, and we have groundwater, which of course needs to be filtered, and we back flush the filters about once a week, and you can see the back flush that's then coming out of these filters, and the sediments that need to be constrained, held back to not clog the emitters. Next slide. This is again the golf course project, and the reason why I'm talking about this a little bit more, next slide, is because it's a project where we have four subsurface drip products in a side-by-side comparison. We work with Toro, Rainbird, Netafim, and Hunter. And you see each one of these products here put in place. Next slide. We used different approaches how to install. Either the sod was completely removed in some of the soil, and then the drip line was put out in a grid, the photo that I showed before, or we trenched into existing turf, and we learned that by trenching in existing turf, it takes longer for the cover to heal, to grow together, and to provide the same uniformity and aesthetic appeal that's required here on that golf course and on that tee box. I mentioned also the reason why we got into this project here was A, because we received some funding, and B, the golf course was not only interested, or the manager's superintendent here, in distributing water uniformly, but they also wanted to cut the waste from overspray, which accounted for a significant amount of water use. We also learned that drip lines, particularly in these sandy soils, cannot be installed too deep, so the 3 to 4 inches need to be kept. Otherwise, you don't have enough water. The capillary raise of that sandy soil is not enough to bring water to the surface, and then you have these dry out areas. Next slide. This just a kind of a time lapse, the same tee box from March to August 2017, and that is drip irrigated. And what you can see here is that not only that the grass grows nicely and you do not see a difference to the sprinkler irrigated ones, but also that the area under irrigation is truly limited only to those strip lines, and you don't have that overspray that you can see on some of the other photos. Water use, those savings are significant. Here, these gray bars show water use of our sprinkler irrigated tees, and then the remaining, the blue and the orange color were the Toro and the Rainbird drip lines, and the green is ET. Now, not only are the drip irrigated numbers significantly lower than the sprinkler, but they're still higher than ET, and ultimately we would like to get more closer to actual ET, but these are numbers from 2016, which A, were the growing phase, so we had to apply more water for the grass to recover and to establish, number one. And number two, all these tee boxes are still irrigated manually, and that is very hard to adjust accurately. But over time, they will be tied into the irrigation controller, and then we will be able to irrigate more accurately. Next slide. There's just each of these tee boxes has a water meter, so we know exactly how much water goes out, and we can correlate with ET, with local ET, with the weather station that is on site. Here you see on the left, you see the superintendent cleaning the filter, always checking and making sure that there is nothing in there that doesn't belong there. And on the lower right, currently those tee boxes are not being aerated. So aerification is not going to be conducted for now. Next slide. We also scaled up our efforts a little bit and worked with the city of Albuquerque and put, this is a 1.5 acre public park, and we split it in half and put one half under drip irrigation and the rest stays on sprinkler irrigation. So it's about 3/4 of an acre each half. And we wanted to make sure if this technology not only works efficiently on the smaller areas, but can also be used on the larger areas. Next slide. Here we have some examples on how not to do it and the things that can go wrong. That it's certainly not a fail-safe approach. We have on the left the water supply was overestimated, and then whoever installed it, we just came to the site late. It was already in place. And the flow and the pressure is not enough to bring enough water for the grass to grow. So you see a little bit of grass growing directly on the drip line, but not in between. On the right photo, you see the drip lines too far apart. And for cool season tall fescue, which is a bunch type grass, the grass grows actively on top of the drip lines, but doesn't spread out in between the drip lines. So this is a combination of, I would say, poor design, poor planning, poor design. Drip lines are 16 inches apart, which is too far. And then you have a non-spreading grass and it stays basically where the water is provided. Next slide. Root intrusion is of concern, and the four manufacturers address the root intrusion differently through different approaches. Toro, for example, has the Treflan incorporated in the drip emitter, and Rainbird and Netafim use copper technology that is supposedly helps prevent root intrusion. Now, this is fairly new technology. To my knowledge, we don't have long-term data just yet whether this works or not. Next slide. Of course, proper installation is key. There is several things wrong here on this installation. On the right, on the left, we have the header line that just ends there open. So you will never have appropriate pressure buildup here. Also, the drip line was not installed deep enough, so it's now exposed on the surface. You can go on and on. This is not how it's supposed to be done, unfortunately. Next slide. This was a project that we accompanied in Albuquerque. Was a soccer field, and the first entire batch of drip lines were actually didn't work properly. You see on the left photo here, the water is not dripping out, it's actually streaming out. So this entire batch had a faulty drip emitter installed, and about 5 acres of drip line needed to be removed and needed to be reinstalled. Next slide. On the left was an interesting problem because we first thought we had clogging, we had emitter clogging, and we're not giving enough water. We went in, we dug up the drip lines and examined the drip lines. There was no clogging. The drip lines were working fine. We underestimated water requirement. We knew about the water requirement for the grasses, but there was a lot of tree roots. There was a significant amount of tree roots growing into this tee box here that actually used most of the water, and that only allowed for the grass to grow just around the drip emitter. So it should have been irrigated to a much higher level, to a much higher amount from the beginning, which wasn't the case. And because we dug up a large area, they then decided to go in, replace the system, and start all over again, which the two photos on the right show. Next photo. So overall, we feel that subsurface drip is certainly a valid approach to irrigate turf efficiently, and also with less water than what we traditionally need through a sprinkler system. We've looked at different water qualities. We've also used drip systems with in conjunction with saline water, low quality water, recycled, treated effluent, groundwater, whatever alternative water sources are available. We've published most, if not all, of our work. It's just there is this, the public perception is such that turf needs to be irrigated from a sprinkler system. And there is more outreach activity, which we try doing through our extension workshops, where we bring people together, work with master gardeners, with local people, and put in drip systems. Okay, next slide. Yeah, and just want to acknowledge companies, funding agency that have supported us over the years in our efforts to irrigate turf more efficiently. And with that, that was it for me, I guess. Thank you.
All right, thank you, Bernd, for your presentation. So to everyone, as you're taking the time to type in your questions to the chat box, we'd like to put up a few quick poll questions. After we take questions from today's speaker, we'll have a few more slides to close out the session and ask one more poll question about topics for future webinars. So our next poll question here, what type of landscapes do you work with? Residential only, commercial only, or a combination of residential and commercial? Okay, looks like we have mostly a combination of both. And our next question, do you need a way to note your attendance of this webinar? If so, we can send an email to attendees who joined both the webinar and phone call portions of the webinar for at least 30 minutes with proof of attendance. All right, thanks. And if you need a proof of attendance, we will send that out after the webinar. And now we'll go on to a few quick questions for our speaker.
Okay, so the first question is, are you using the low quarter DU for scheduling purposes or the low half DU?
We use, well, we have used the low quarter, but we have recently converted to the midpoint to the low half. We use the low quarter to assess an irrigation system, to determine its irrigation uniformity, that's what we use. That's what we use the low quarter. But for irrigation scheduling, recently we've converted to the low half.
Okay, great. And then the next question is, are air release valves necessary when dealing with drip line with check valves?
Good question. These check valves actually have come on the market very recently, probably the last 2 years, at least that we are aware of. So maybe because we're just philosophically, emotionally still attached to our air release valves, we still put them in. It's not a major investment, and it just, I guess, keeps us a little bit more on the safe side. But theoretically, you wouldn't need them anymore.
Okay, thanks. The next question is the integrity of the subsurface drip line system and components a concern during the winter and cold climates?
Also, excellent question. So we here in southern New Mexico, we don't blow out irrigation systems in the winter because our winter, the temperatures stay only a few degrees below or always above. Up north, they do blow out the system. The example that I showed was actually in Santa Fe, and they blow out the system. Now the drip lines themselves are actually flexible PVC, and the manufacturers do say that they allow for freezing and thawing. It's usually the header lines that if they are solid PVC, then they need to be emptied out for the winter and prepared for the winter.
Great, thank you. So our second to last question is, are there any issues with subsurface drip for turf with reclaimed water?
The issues affecting the drip system themselves, no, we have not come across any issues. The systems just work as fine as they work with potable water. The problem is more related to the turf stand itself, to the plants, because effluent has a higher salinity. So salinity accumulation in the root zone needs to be addressed one point or another. But the system itself is not affected, at least with the water qualities that we worked with in the past.
Okay, great. We're just having a few more questions come in.
That would actually be almost a presentation by itself, how to run and operate a subsurface system with low quality or with non-potable water. That's a whole new ball game.
Okay, great. So this will be the last question during the webinar, but for other people who submitted questions, we will follow up with you at a later point. But for now, do you recommend installing any deeper when soils are loam to clay loam?
Yeah. Well, yes and no. That's a very tricky question, because on the one side, of course, you have on the loamy clay soil, on the finer textured soils, you have a much greater capillary raise than you have in the sandy soils. So in theory, that would allow you to go with your drip lines deeper. On the other side, your rate that water moves is much slower. And sometimes the rate that water moves in the soil is actually slower than the drip emitter can, or I should say, the drip emitter delivers water faster than the water can move in the soil, and then it just pressures up to the surface. So the 4 inches that I mentioned in my presentation is actually a very good number across all soil types. What needs to be considered is then adjusting the run times for the different soil types. Yeah,
All right.
I want to keep it short, the answer. I mean, I could go on and on here, but I guess for the purpose of the time here, let's keep it short.
That's fine, and thank you, Bernd. We definitely had a lot of questions come in towards the end. So everyone that asked a question and we were not able to get to it, we will absolutely follow up after the webinar, and we will email out the answers to you. And if you do have any questions, still feel free to type them in the chat box. We're going to go ahead and finish out with a few more slides and one more poll question. So some of you may already be WaterSense partners, but we might be new to others. Our program depends on our partners to carry the message of water efficiency to consumers. These are the categories of partners that we have. Many of the utility and government organizations on the call today fall into our promotional partner category. I want to encourage you to become a WaterSense partner. After all, it's free, and we have a lot of materials to help you communicate water efficiency. If you're an irrigation professional, consider one of our WaterSense labeled certification programs. These programs offer certification in irrigation system design, installation and maintenance, and irrigation system auditing. Currently, over 2,800 professionals have been certified by WaterSense labeled programs across the country. These certified irrigation professionals are listed in our directory of certified professionals on the WaterSense website. And if you are a property manager looking to improve your landscape, you can use the directory of certified professionals to search for an irrigation contractor in your area. And finally, our last poll question. Hopefully you're finding these webinars to be beneficial. We'd like your input on potential topics for future webinars. What webinar topics are you interested in for the future? All right, thanks for that. It looks like we kind of have an even split between most of them, with the majority going for water conservation in urban communities. And if there was a topic you saw here, or if there was a topic that you did not see here but you would like to see in the future, please feel free to type that in the chat box as well. Thank you to our speakers, Marianne Dickinson and Bernd Leinauer, for your presentations today. And thank you to everyone that has joined our webinar. Have a great day.